talking about.
No, we're done. Hey, stop. We're done. We have to stay focused. Yeah. Alright, concentration. It's the measure of the amount of solute that is dissolved in the solvent. I talked about this a couple days ago, that what's concentrated to you might not be the same as what's concentrated to me. And we need to actually quantify it to know exactly how concentrated it is. For example, could I maybe say exactly how much solute I had with a number dissolved in the solvent? Is that possible? Yeah, I mean, we're probably not going to be able to count it, but we could use some things that we've done in the past, like maybe some stoichiometry things.
Oh, shoot.
Okay, so there are a lot of different forms of concentration. We're going to focus on 4. 2 of them are more important than the others, but I'm going to show you all of them. Okay, the first way to figure out how concentrated something is would be to take the mass of your solute that you dissolve. So could I weigh a certain amount of salt and then put it in a liquid and dissolve it? Is that possible?
Yeah.
And could I weigh the amount of solvent, or could I weigh the solution after I've dissolved everything? Yeah. And that would be able to tell me, right? Because if I said, 14% of the solution is solute versus that doesn't make any sense, versus 40% of the solution is solute, which one's more concentrated? 40%. If I have 40% of the solution is made up of solute, that's going to be a more concentrated solution than 12% of the solution is made up of solute particles. Okay? We're able to actually quantify a number. And I don't think I actually give this to you. You have to write it in. Is that correct?
Yeah.
Yeah. So you guys make sure you write this in because I didn't specifically give it to you. Now, what's most difficult about these 4 equations that I'm going to give you is you've got to get the units right. You've got to know that it is solute, not solvent, and that this is solution, not solvent. Okay, because each of them is going to be a little bit different. Some want solute, some want solvent, some want solution. Okay, that's probably the most difficult part about today. The math isn't crazy difficult. For example, if I'm doing this problem, it gives me the amount of solute right there. If 4.81 grams of salt is dissolved in water to make a 56.3 gram solution, what's the percent mass? Well, solute divided by solution times 100. Oh, that's hard.
Let's get our handy dandy.
Get your calculators out.
10.32.
Now stop though. Could they give you solute and then give you solvent?
Yeah.
What would you do to do percent mass if they gave you solute and solvent?
The same thing.
No. You would add the 2 together to get the mass of your solution.
You're working on my
Right? Because isn't a solute and a solvent make up the solution?
Yes.
Yeah.
Okay? Very important.
Oh.
Because they could give you solvent. So that's why I said, knowing the units, that it has to be solute over solution. And I'm going to abbreviate solution SOLN. Okay, I'll abbreviate solvent SOLD. Okay? It's important to note that. And that's what this one's asking. So we can do this relatively quickly. I'll just erase this. My solute is my sugar.
10 over
10.
100.
But then it gave me the grams of water, which is my solvent. Solvent and solute make up the solution.
So
Add them and you should get 100, which is just 10%. So not overly difficult, but I wanted to point that out and make sure that you understand that the units here are important. And in a way, the substance is also part of the unit. Questions on this? None? And volume. I think you have to write this in as well, right?
Yeah.
grams of the same one? Well, they could, and then you can use density.
Moles
Actually.
per liter.
You would, not with that. All right, now listen. I'm not going to show you an example of this because it's the same process as doing it with mass. It's just now with volume. Okay, but I do want to make a point here. Okay, these first two ones that I've shown you are one way to figure out how concentrated something is, but it's not the best way. For example, if I took the same amount of salt and dissolved the same amount of sugar, that doesn't mean they're, when I say same amount, I mean same mass. Okay, I shouldn't say same amount, same mass. If I take the same mass of salt and the same mass of sugar and I dissolve it, their percent mass is going to be identical, right? Okay, but that doesn't mean one is more concentrated than the other. One could actually taste more concentrated than the other because the particle's size is different. Does that make sense? So technically, you could have a less sugar dissolved and still have the same mass because sugar is a bigger particle. Does that make sense? So these are great ways to get you an idea, but they're not the best way, because the best way to know how concentrated something is to exactly know how many particles you have dissolved. Okay? Because the mass of the particle doesn't make it taste more concentrated. How many particles you have is what makes it taste more concentrated. So, the next time, what is our most common particle unit we've dealt with?
Moles.
Moles. And that's what molarity is.
Oh, molarity. All right.
There it is. This is your molarity kind of equation, but it's more of a unit than it is an equation.
Molarity.
We'll wait till we get to the next one, which is molality.
Immorality.
Ah!
Molarity, you might want to make a note by this. Molarity is the most common concentration one that we're going to do. It's the most important concentration equation. Molality is the second most important, but we probably use molarity the most. Okay, now I want to make something clear. I can say I have a 15 molar solution. What does that mean? Because this is probably how I'm going to show the unit. But this unit is a derived unit. It's also the same as saying I have 15 moles per liter. So, when I take an answer and I say 15m, what that means is I have 15 moles that I have dissolved in so many liters of solution. Got it? Okay. Now, if I want to solve for this, I would have to take the moles and divide it by the liters to get per liter. And we'll get to that as we progress. There's actually quite a bit of ways to do these problems. So you kind of got to step back and plan out how you're going to solve this. Look at what you've been given, jot it down, and plan out what you're going to do. It says, dissolving 345 grams of HCl to make a 3.75 liter solution results in what molarity? So, we know I got 345 grams of HCl. I should probably identify if that's the solute or the solvent.
Solute.
That's important. All right? Now, it gave us 3.75 liters, but is that the volume of the solute, the solvent, or the solution? Okay? All right? Now, we want molarity. What is molarity's units?
Moles. Gram.
Moles
Per liter
of
solute.
solute
Oh, it's
divided by liters of solution. So I need to find the moles and divide it by the volume.
so
We have the volume already. That's good. But what do we not have?
Moles.
We don't have the moles of solute, but we do have something that we can use to find the moles. What's that conversion called? Molar mass.
Around 2.2.
Okay, this isn't going anywhere. I told you that molar mass wasn't going to go anywhere. So we could do it all in one step, but I almost think sometimes for you guys it's a little easier to just break it down. Let's take that and convert it to moles. Okay, first units. And remember, molar mass is always per 1 mole. Where do we get the gram number
From
from?
the periodic table.
Periodic table.
1.01 plus
Okay.
36.
35.5.
Okay, so hydrogen is 1.01. I only have one of them. Chlorine is 35.45. I only have one of them. Add them together, you get.
36.46.
Is everybody? Is this coming back to you for molar mass? I don't have to explain it in great detail, do I? Anybody? Okay. So what did you guys say it was?
36.46.
46.46. That's going to take.
36.
Why don't you tell me right? I should have known better. All right. What does that give you for the mole number?
9.46.
Well, because we're not at our final answer. Let's go a little bit more.
9.46242.
Let's go like that. All right. Moles of my solute. Are we done?
No.
All right.
Now you
Because we
got-
want molarity, right? And molarity is how many moles per liter. Well, we know how many moles we have, and we know the total volume we have, but we can solve then how much per 1 liter that is. And that would be taking your mole number and divided by your volume should give me the amount of moles for every 1 liter.
Yeah, 2.5.
Oh, I think that too.
Sig figs, 2.52. And notice how I just abbreviated big M. Why did I do that? Because big M is moles per liter, correct? Questions? Alright. Next problem. Alright, this is a little bit trickier. Well, not trickier, but a different way. Typical chemistry. I'll show you the front door. Now we'll walk in through the window in the back.
No, you gotta go backwards.
Kind of, yeah. So,
Why doesn't this house just have one open?
because it's not reality. We got to do reality here.
It's always
Do
fun
you
to
go
jump out
through your
the
window usually?
If I have to.
When do you have to?
Well, one time my son accidentally fell out the window.
Oh.
You told us about that last time.
I remember that.
So it says you have 0.6 liters.
Wait, it just says these guys, I think it is?
No.
It's yeah, but it's different. It's different. So it is easy once you understand what it is it wants and how to go about doing it. But it is something different than last. Then they gave us 0.5 molar. Well, let's write that the long way. What do I mean by that?
Grams per dumb way.
No.
No, wait.
What is molarity?
Moles per liter.
Moles for every 1 liter. Does that make sense? The reason why I want to do that is because when you're given molarity, you're usually using it as a conversion factor. Okay? Then it says, how many moles does this solution contain? Notice how I have a volume and a volume, and I could step that up.
Why do you have it in a fraction?
Because I'm going to use that as a conversion factor.
It should be 0.5 times 1.
No. It's the amount of moles per liter divided by.
Provided by.
Sure about that?
I'm 100% sure about that.
Wow.
Yeah.
What are the questions?
And so like in the previous example, we had like 9 or some moles in 3.5 liters. And And what we did was we divided to figure out exactly how many moles for every 1 liter you have. Or per 1 liter. Per means divide. Okay? So then if you look at this, you see how I could set, using this as a conversion factor, get my liters to cancel out and solve for moles. Let me show you. Where would I keep it as is? Would I flip it? What would I do? And I want liters to cancel out. Are we pretty familiar with conversion factors up to this point? Have we talked about unit cancellations? Have we? I know that the solution has half a mole for a liter, but if I don't have a liter, then I'm going to probably have less than half a mole, don't you think?
Yeah, it's gonna be 0.3.
1 sig fig.
Oh.
So here's my general rule. This isn't always and every, but usually if they give you molarity, you use it as a conversion factor. If they ask you to solve for molarity, then you're just solving for it. Now, stop and listen. This is really important. What if they told me how many moles I had, and they wanted to know the volume of solution? Could you take this and flip it? Start with moles, cancel moles out by flipping it, and then solve for volume? Is that possible? Do you remember in the stoichiometry tracker, sometimes we went from grams to moles, but sometimes we went from moles to grams, and so that depended upon whether I had it one way versus flipped? You remember that? You can do the same thing with molarity. It's no different.
I was thinking you just do 0.5 times X amount of liters. And then just plug in the whatever.
You're talking about a proportion? It ends up being the same thing when you set up a correct proportion. I mean, I like proportions, but it doesn't tell you as much about how units cancel. And that's why I tend to sit on unit conversions, because understanding units is really vital to being successful in really most science classes. Okay, so we got a chemical reaction that requires 0.18 moles of AgNO3. I'm guessing that's probably my solute.
Yep.
Okay? Hey, this is just what I said is possible a second ago. They gave you molarity. If they give you molarity, you usually use it as a conversion factor. 0.8 over 1 if you write it out. That's what big M represents. And then what do they ask you to find? Not Y in milliliters, I know. They asked me to find volume. Could I set this up so that moles cancel out and give us volume? Yep. But notice what I have to do with this.
Flip it.
Flip it. Everybody see that? It doesn't change that they equal each other. I'm just switching it so that I can solve for a different unit. So that doesn't mean I'm taking 0.8 and putting it with the liters. No, I'm taking it, doing the reciprocal of it. So 0.8 moles, 1 liter. Now, I'm going to go ahead and go another step further, because it didn't want the volume in liters, did it? We want it in milliliters. So could I add a second conversion factor up here to convert them to milliliters?
Good, or you could just move the decimal.
You could just move the decimal when you're done. You're right. But I want to get to a little bit of review on how to do unit conversions between our metric units. Do you remember where the one always goes?
Double.
With
Why is it
prefix.
not milliliters?
Because that's what we want to solve for. We have to cancel out.
Okay.
Yep. Remember 1 always goes to the prefix unit. Remember that? At your start in your notes. Milli is 10 to the negative 3. And yes, you could just solve for this and then move the decimal if you're good at moving the decimal. Okay? but I just want to make sure and review because a lot of times kids get to become physics students and they still don't know how to do this, even though I showed them as a physical science student and I made them do it as a chemistry student, and they still can't do it as a physics student. When you plug this in, you should get 225 milliliters. Does that agree with what you got?
Yes.
All right. Last one. Molality, slightly different. The top part is exactly the same. The most difficult thing about this section is you must know what each of these things represent. And not just moles and kilograms, but solute, solvent. This is the first of the four that has what in it? Kilograms and solvent. Isn't that right? Everything up to this point has had solution, correct?
Oh.
Okay? Make that note. It's very important. This problem looks very similar to the first molarity problem in that they gave me a mass. Okay? And they gave me a different mass. They didn't give me volume, but it's the same idea. Let's write down and identify what these are. 271 grams is the what? Whoops. That's our solute. Why is it the solute?
It's added to the.
Okay, it's also less than. And there's our what? It's water, it's our solvent. It better be our solvent, we need it.
That's really awkward.
Okay, and then it wants molarity. So just to help us, let's write what molarity equals. Moles of
The solute
over
solvent.
kilograms of solvent. Alright, I need to get those two things so that I can divide them. I know what the solute is and I know what the solvent is, but technically I don't have either in the correct unit, do I? The bottom one's probably the easiest to get in the correct unit. Can I just easily move the decimal and get kilograms here? Okay, move it 3 spots to the left. That'll give me 0.724 kilograms. Does that make sense? Everybody?
Yeah.
And then, doesn't this look similar to what we did earlier? What do we need to do? Okay, well,
Divide.
convert it to
Moles.
So you're gonna divide it by 98.09.
you need to convert to moles using molar mass, just like we did earlier today. In 1 mole of substance, what's the mass? We would have to go over to our periodic table and look at the periodic table.
98.
This is a little bit trickier because I have more than just one of each. So you would have 2 of your hydrogen, which is 1.01 for the periodic table, right? Plus 1 of your sulfur, which is I think 32.07, is that right? What are the molar mass? What's the molar mass of sulfur? Is it 32.07? Okay. Add that all together, and you said it was what?
98.09.
98.09? I will then convert my solute from grams to moles. I don't have this.
2.76.
2.76. Do I have a second on that?
Yeah.
Yeah.
Nice. So what would I do to finish?
You have to make the other one kilograms.
I already did it.
Oh, that's good.
Plug it in.
Plug it in and divide. Right? Everybody good with that?
Yeah.
Take this, plug it in here. When you divide, you will get your molality, which is
7.81.
and it's little m. Now notice, molarity is big M, molality is little m, so there is a little bit of stuff that you do have to engage in.
That's true. Molality is a lot of L's and it's lot of.
I think it's time to go. Let me just, this is exactly like the last problem. You were given solvent in mass, you would need to convert it to moles. And you were given solvent in grams, you just convert it to kilograms and divide.
Interesting.
Today went pretty well. Good job, guys. Focusing.
Thank you.
Good. What were you saying about that?
5.